All right, so we'll kind of keep going here. First of all, what should be done by the end of the day today? That first homework, okay? So next week, probably even after class Monday, I'll put up the next homework. It'll be quite a ways off. It'll just be kind of getting it out there. So like I said, you can kind of work on it as we move through the material, right? Obviously, when I assign it early next week, we haven't covered any of it, but it's out there so that you can kind of work and you don't have to save it all to the last day. Like hopefully no one here is doing today, but I can see in the grade book what's done. So I know some of you are in that boat. So we left off last class. Well, are there any questions for me before we kind of dive into the material for the day? So we were using this asphalt example. We were thinking about changes that simultaneously occur in supply and demand and how we can understand those changes. So, we had all these effects. Here's kind of some summaries. We'll work through a couple more examples now, but you can imagine I could have a demand decrease, supply increase, demand increase, supply decrease, or I could see both demand and supply increase and both supply and demand decrease. Right? Those are like my four combinations, right? But as long as I understand how to work through one of those problems, I can work through all of it, right? Now the end result will be a little bit different, but once I understand how to draw and how to solve these simultaneous shift issues, right? I can do it for any of these four combinations, right? So I left this blank, or no, sorry, I think I have a blank slide here. Yeah, I do. But we'll work through a problem here in a second. I'll kind of come back to this afterwards. I ended last class saying, break down the effects. We have simultaneous changes. Write down the effects that the supply change would have. Write down the effects that the demand change would have. And then the total effect becomes a little bit easier to see. Notice if I saw demand and supply increase, well, if demand increases, price and quantity go up. But if supply increases, price goes down and quantity goes up. So they both force the equilibrium quantity to increase, but they have opposite effects in the price. So what I would say is both these changes happen at the same time. I know that equilibrium quantity will increase, but the change in equilibrium price is indeterminate. It depends on which one of these shifts or these effects is larger. So this is kind of the shorthand using the arrows, but I'll kind of go through and draw it graphically as well. So let's think of, I was thinking of what type of example we have, right? Because I can come up with a bunch of different combinations of, okay, technology improved and, the income went up and this is a normal good. What's gonna happen to equilibrium? We have to think, okay, there's two changes. One of them affects supply, one affects demand. Which is an increase or decrease, and then kind of think about what the end result would be, right? I can come up with another example where I'm saying, in fact, if I could do that, we might work through one of these, but the government increases taxes. I can increase input prices, and right, we see that the price of substitute goods goes up. What's going to change? How's the equilibrium in the market that change? Well, both of those things, one would affect supply, one would affect demand, would it increase or decrease? I'll come up with a bunch of different scenarios. So the one we're going to use is a little bit unique to today. Is actually like only one change, but it's something that's going to affect both supply and demand. So let's just start out. We'll get our original starting point. Supply represents our marginal costs. Demand reflects our marginal benefit. And when I'm writing, I had someone stop on my office and ask me a question. Remember, these stars are kind of representing it's the equilibrium. And then I'm just using numbers to kind of say, okay, this is where we started. After the change, this is where the new equilibrium is. So we know that this is the equilibrium point because it's where supply is equal to demand, or where the marginal benefit to the consumer of the last unit consumed is the same as the marginal cost of whoever the producer was that supplied it to the market. So let's say, I want to make sure, I want to see this. Let's say the change we have is that expected prices in the future are lower. So we expect prices in the future to be lower. So as we're working through things that shift both supply and demand, you should have noticed there was one of them that might have affected both, right? Just one change, which would be this expected price. So what are the impacts of this expected price being lower in the future? Which curve, kind of already mentioned, it's going to affect both curves, right? How is it going to change demand? Current demand is actually going to decrease. Because if I expect prices to be smaller tomorrow or lower tomorrow, I'm going to hold off on buying it today and try to wait, right? So current demand is going to decrease, right? If people expect lower prices in the future, the consumers are like, well, I'm going to try to buy it even if it's a month from now, right? That's when the prices start to be lower. What impact is it going to have on supply? Expected prices are lower tomorrow. Sellers of this good, they're going to want to sell it today, right? The price for them is a good thing, right? That's the money they get to eat. So we're actually going to see that if they expect lower prices tomorrow, I want to try to sell it today, right, before those prices go down. So this is a kind of a unique scenario where we do have simultaneous changes to supply and demand, but it's coming from the same kind of change, right? Only one thing changed, and it influenced both of them. Any questions on anything that's said there, kind of why the expected price changes do that? So we could draw them on the same graph, right? Or we could draw them out individually. I'll draw them out individually and then kind of show you why I did that. If we try to draw the same graph, so kind of work through this again. So let's just first do the demand decrease. What does a demand decrease look like? I draw the line here or here. Yeah, right. If it's decreasing, it's getting closer to the quantity 0 point, right? So it's going to the left. So at any given price, the quantity demanded is now going to be lower. So we're going to see this kind of decrease in supply, decrease in demand, right? So our new equilibrium is where our new demand curve hits that supply curve. So if we try to then map this out, we're going to end up with our new, I'll get out of the way in a second, our new equilibrium price and quantity. Equilibrium quantity went down, and this demand decrease forced the equilibrium price down. So our demand decrease had the following effects. And I don't know how you want to write this. I usually like using arrow, or use an equal sign, or just draw a line. I'm just trying to say that this demand decrease led to equilibrium prices being lower and the equilibrium quantity being lower. I don't know if you saw that, but all right. So we got one of the changes. So let's go. I'm just going to draw what we originally had so that we can understand how the supply chain is going to impact things. Redrawing, we had in black there. I'll get out of the way in a second so you can kind of copy it down. So identify our equilibrium point. The second thing that changed expected prices there was an increased supply. So is the increased supply going to be up here and down here? So a supply increase, if I draw it here, oh no. What's that actually saying? It's actually saying that every price supply is going down. Or right, this is the supply is the tricky one, right? Because if supply is going this way, it's actually getting closer to that zero point. So, and that's why I use that terminology a little bit on purpose, tricky, because right, thinking about this up and down is not how we want to think about it. Right, that's what causes us to make this easy mistake with supply. The way we want to think about if supply is increasing, that is a shift to the right. That is a shift away from that quantity 0 point, right? Supply is increasing, right? It's moving away from that 0 point. If supply goes left, it's getting closer, right? Closer to that 0 point. So that would be a supply decrease, would be to the left. So I've got my rightward shift from an increase in supply. Right? It was something like that. Any questions on? Like I said, the supply shifts, I know they're just like, it's so intuitive, it's easy to think about. The visual doesn't line up. So it's a right and a leftward shift. Right? Leftward shift is decrease, rightward shift is increase. Same kind of thing applies for demand. So you can memorize that rule for both of them, and then you can do all right. So without me identifying it, what has happened to the equilibrium price and quantity just from the supply increase? So where's the new equilibrium point? Where supply is equal to demand. So what's happened to the equilibrium price and quantity? Prices went down, quantities went up. So the effects of that supply increase, right, were that it drove the price down and the equilibrium quantity up, right? So drawing these on their own, right, helps me understand each changes or each shift's effect, and then I can kind of come up with, well, what was the total effect, right, that existed from these lower expected prices? Well, it caused two things to shift. They both pushed price down. However, they put quantity, kind of had different influences on quantity. So if I want to draw kind of my arrow side to side, or just say that like, I really don't know. The change to equilibrium quantity is indeterminate. I would need to know which one of these effects was larger. Right? Were consumers more responsive to this lower expected price, or were the producers more responsive to that lower price? And I don't have that information. So we would say the equilibrium price will go down, right? But we can't say what's going to happen to the equilibrium quantity. Any questions at this point about how taking this approach to this type of problem? So what is the danger of drawing these on this graph at the same time? I won't draw it because I think me drawing it maybe gets a little confusing. I kind of like the synopsis. So we had what, a supply increase and a demand decrease. So this is the guy that we had, right? Demand decrease, supply increase. You can kind of see, it depends on which of, like how I draw this, right? If I were to draw the demand decrease as really big, and then just a small supply increase, maybe my new equilibrium is here, and prices are lower, but quantity also looks like it's lower. If I instead drew the really large increase in supply, but a really small change in demand, well, now my equilibrium point's here. Price still looks like it's lower, but quantity actually looks like it's increased, right? So when I have simultaneous effects, a lot of the times if I graph them on the same graph, I come up with different conclusions depending on how accurate I am at drawing, my shifts. In fact, if they saw the exact same shift, notice here, this is what I tried to draw for you last class, it'll show lower prices, but that equilibrium quantity could actually remain unchanged. So anytime we have simultaneous shifts, there's always going to be this kind of gray area, which is why we don't want to just draw it on the same graph. It can lead us to the wrong conclusion. However, if we draw each change individually and then look at the impacts of each one of those shifts, it's a little bit easier to kind of see what that total effect would be. And when I say it's easier to identify when changes would be indeterminate.
So if we got a question asking something like this, would you just want us to say it was indeterminate, or would you have to try and explain?
Nope. So like if you were given, you could just like with a short answer, you could say equilibrium changes are indeterminate, right? I wouldn't give bonus points, but in my heart I give bonus points if you told me that it depended on the relative size of the shifts, right? Like I'm not giving you any question where I tell you, well, this shift is larger. And so then I wouldn't actually do that, but knowing that, it's like next level, I would be impressed. But yeah, more often than not, like if I give a multiple choice, one of the possible answers would be literally like quantity changes indeterminate or cannot be determined. And those two phrases. Good question. Any other questions on kind of approaching the simultaneous shift problem? Like I said, we can work through a number of them. There's so many combinations of this thing that changes demand and this thing that changes quantity and what's the end result. So we have an endless number of examples we could work through. We did one last class, we worked through a different one here. I can also think about one thing that I did, I think we did in class, so I just wanted to kind of reiterate it. That, first of all, does everybody have this? One thing that we talked about that I don't believe I had show up in the slides, or if I did, I just really want to make a strong point of it, is that one thing that we can see that changes supplier demand would also be, so let's see, we saw an increase in taxes. And let's say, income is decreasing. So I'm going to think about the market for I'll get out of the way in a second. So I'm going to think about the market for cigarettes. Okay? So this would be a type of problem where I have to give you a little more information. Right? So we got taxes increases. That's going to impact which curve, supply or demand. So the way that suppliers, the way that we'll think about taxes, the way they operate, is taxes are initially like we're used to like thinking about it as like the consumer is paying the taxes, but really the tax initiates at the producer. It's just passed on at every level, right? So that it's always incorporated in the tax. So we'd see this increase in taxes actually impacts the supply. Let's then think about, we also see a decrease in income, right? Kind of overall across the US. So I can draw the supply chain. What's income going to shift? Demand, right? Consumers' incomes, right? As they go up or down, changes how much they buy of a good. But I need one more piece of information. What do I need to know about cigarettes? So income changes, if they're normal good, can have very different effects on if it's a normal or inferior good. So let's say I tell you that cigarettes actually, look at it, tend to be inferior good. Right? When we look at kind of the income brackets, we see that cigarette consumption is the highest at the lower end, higher at the lower end than it is at the upper. We can probably debate whether or not it is inferior to normal, but for most, all intents and purposes, it looks like in the data that it is inferior. So we draw these out, these kind of changes out simultaneously. But that's going to be a problem because we might have an indeterminate that it goes up or down. So we draw these independently. The first one's taxes, right? So they're going to change the supply curve. It's going to increase or decrease our supply. Right? If it's now more expensive to produce the same thing, right? It's the old price plus whatever the new taxes. I'm going to actually see this supply decrease, right? Or a leftward shift. Think about my supply plus the tax. Or think about differently, at every quantity, if this reflects marginal cost, right? It's marginal cost plus tax now. Right? At every quantity, the marginal cost is now higher. How much higher? The amount of the tax. Right? So I've got my supply decrease, the leftward shift. What's that going to do overall? Well, it drives my equilibrium. The price is up, and it drives my equilibrium quantity down. All right? So price is up, quantity down. I could draw this on the same graph, right? But just try to only identify kind of the movement. So maybe it's easier to probably draw it separately. I'll do it in different colors so that we can kind of see here. We've already worked with some examples. But this income decrease is going to cause the demand for an inferior good to be what? Yeah, inferior goods we said is when I have less money, I actually buy more of them, right? It's like ramen noodles, Natty Light. So lower income, we're gonna actually see an increase in demand. So this increase in demand, right, moving away from that 0 point, so it's moving to the right. You can think about what's that new demand curve? How would it change the equilibrium? Well, we're not going to worry about simultaneous changes. We can almost like ignore that I did any of this green work. Where would this new demand curve hit the old supply curve? Right? And then now we're just getting, okay, what are the impacts of just the demand shift? So our new equilibrium is up here. You can kind of see, okay, prices went up, quantities went up. Right? We don't have to, we could, so I should have called this 3, but we could actually plot these points if we wanted to. Well, you can kind of see from the original point, quantities went up and prices went up. So this demand increase pushed prices and quantities up, right? Or the equilibrium price and quantity. Now that I have both of these shifts effects, I can think about the total effect. So what's going to happen to prices? Both of these shifts. Price goes up. Increased price, right? Right? They both cause price to go up. So the total effect will be that price goes up. However, if we look at quantity, right, the supply decrease caused equilibrium quantities to fall, demand increase caused equilibrium quantities to rise. And so this is one where we said we're using arrows to determine, to represent indeterminate, or that we can't determine. I just draw this sideways arrow. We really don't know what's going to happen with equilibrium quantity. Questions on that example? So kind of this idea of using taxes as something that could shift supply. I might use those examples in the future. So, excuse me. Examples that we just worked through had quantity being indeterminate, but if we have the right combination of demand and supply changes, we actually could end up with prices being indeterminate as well. So it doesn't just have to be quantity. I was really clear about that, since the 2 examples we worked through today had indeterminate quantity. I believe the one that we worked through on Wednesday, I think it was this one right here. I think we had an indeterminate price. All right, so here's like kind of the shorthand summary of the 4 different combinations you could see of demand supply shifts. I had the visual representations of them. I could ask an quickly question, but we might come back to this. We'll come back to that or show the answer. So maybe we'll come back. Maybe when we've worked through enough examples, I think we'll be okay. Yeah.
Are you going to go over like the shaded part of the year?
The shaded
Like
of these.
on homework, the first 2 questions they had asked us to like do the triangle part, but she was shaded. Like I got it wrong when when they explained it, I didn't understand.
So the first few problems should have just been like how to use the graphing tools.
The first few problems after.
Oh, okay.
They kind of combine them, but like.
Yeah, okay. What was the question specifically asking about?
Like, it had asked us to like graph like what should be shaded, but like when I got it wrong, they explained it, like I didn't understand like why. So I was wondering like if you could just go over like why it should be shaded. Like above
With simultaneous shifts? Or are you talking about like I don't know if you're talking about if you have it, so maybe we'll hold off on. If you have a specific question or a homework problem, that's probably a good thing, like either email me about, stop by my office, or we can talk about it after class. Because I don't have them all memorized exactly what the problem would be. If you're talking about how I know which areas to shade here, it basically comes down to like the shaded area is going to be wherever I see the simultaneous shifts kind of pushing it in opposite directions. So if I think about here, if I wanted to draw these out on the same curve, I know that demand is pushing equilibrium price and quantity up. I know that my supply curve is pushing equilibrium quantity down and price up. So I know that as this demand pushes this up, supply is going this way. My new equilibrium is going to be somewhere up above here, right? Because the demand shifting here, supply shifting here. So it's going to have to be somewhere in that range. So I know it'll be above the demand curve, my demand shifting up. I know it'll be kind of I guess visually it looks like it's above, but if I look below the supply curve, it's decreased. So I know that somewhere in this area is going to be where the new supply and demand is set. So the way that you know where the shaded area is it's really wherever direction your shifts are going. So here, if I see a demand increase and a supply decrease, I can almost like shade the area that would be above demand and would also be above, or kind of, sorry, I said above, but like it was decreasing, right? Kind of in this area of the supply curve. Like think about the potential overlap of where your new demand and your new supply curve could be, right? I could just see demand go like this and supply go like this, or up here, up here. So all these spots would be potential like new intersections, right? So it's going to be the area, the intersection or the overlap of the direction that your shifts are. So notice here, demand decrease, supply increase. Well, supply increases are going to push me to be in this range. Demand decreases are going to push me to be in this range. And so kind of the overlap of those ranges is where that shaded area would be. Or think about it this way. One more way to think about it. If I were to draw the effects individually, I can see here that price is going to go up, and I don't know what's going to happen in quantity. So if I think about where I have a supply, if it has demand increase, supply decrease, so this would be the one that represents it. Well, if I know that my total effect is that price has to be higher, but I don't know about quantity, from the original point, I know that, okay, price has to be higher, but the quantity could be anywhere, right, in this range, in between the supply. And then if I had another example where I know that quantity is going to go down, but the price could be higher or lower, well, then I know that all the quantities that are lower, but the price is somewhere in between my original demand and supply curve has to be where my new equilibrium lies, somewhere in that range. So that's another way of thinking about it. But yeah, for specific questions, you can look at it after class or send me an email. Or... All right. Any other questions? We can move in. All right. So the next thing we're going to talk about is, inefficiency may not be exactly the right word, but we can think about how markets may not end up at this equilibrium point. Okay? So we look at kind of a demand and supply schedule, right? Market demand, market supply at any different, these different prices. Right? We'd say we have a surplus, right? I mean, you've probably heard this term used. A surplus is when there's more of something than we can use, right? So in the relationship between supply and demand, there's a surplus if the quantity supplied, right? Excuse me, is greater than the quantity demanded, right? If we're at a price where the quantity supplied is greater than the quantity demanded, we would say we would have a surplus at that price. So we can go through each one of these prices. Think about it, a price of 0. The quantity demanded is 24, quantity supplied is 0, right? We don't have a surplus, right? The only value, the prices for which we have a surplus are 4, 5, and 6, because for these prices, the amount demanded is significantly lower than the amount that will be supplied on the market. Right? So if we think about like a price of 5, using some actual values here, we would have at a price of 5, 9 people would want to purchase this good, or across everyone, 9 units of this good would be purchased. And the amount that producers would be willing to supply would be 25 units. So the surplus, if the price was forced to be $5, would be the difference between those two. There we go. So 25 minus 9, or a surplus of 16. Right? Right? How many excess units we have? At the price of 5, we'd have 25 units, or 25 producers willing to supply 25 units, and consumers only willing to purchase 9. So we've got an additional 16 units out there that producers want to make, but nobody wants to buy. Okay. Any questions on that? It's not too bad. Okay. So we can kind of think about visually, right? What does that look like? Well, if I've got my market, I know the equilibrium price should be $3, right? And I should be kind of this equilibrium quantity of, is it 15? However, let's say for some reason, right, the price of this unit is set by the government, and they set it at $5. Well, at $5, there's going to be a lot more producers willing to provide units to the market, but at that higher price, consumers, right, move back and the quantity demanded is less, right? So the price of $5, the quantity demanded is whatever point we'd be at on the demand curve, right? Remember, demand and supply are different than quantity demanded and quantity supplied. Quantity demanded and quantity supplied will only change when we see price changes of that good. So here, moving away from that equilibrium point where the government sets the price at $5, quantity demanded is the point we're at on our demand curve. So you look down, looks like 9 units, quantity supplied at $5 is going to be 25 units, right? So the difference between that quantity supplied and quantity demanded, that represents our surplus. So you can almost think about it at every single price, as my price lowers from 5, what's happening to my surplus? So if I'm starting out at this price of $5, and then I start to see, yeah, as that price gets lower and lower, that surplus is shrinking. Right? So why do we always end up in equilibrium? So let's say that, for whatever reason, the price was $5, and on the market, everyone was selling for $5. Government's not necessarily now imposing this price. What's going to happen is these people who are producing the good and can't sell it, eventually, well, I can't just, I'm not producing these goods for fun, right? If it's costing me something and I can't sell it, I'm really losing out. So what happens is you start to lower the price. As the price gets lower, people start being willing to buy more and more. Now there's a smaller surplus. As more and more producers say, okay, well, I need to get rid of this surplus. I can't just have it laying around, right? It's costing me money. The price continues to fall until eventually we get to this point where producers, the amount they're supplying is exactly how much is being purchased, and that's we kind of then sell at that point, right? So if the price were for some reason above equilibrium, it would kind of over time, or probably relatively quickly, you would see price decreases until we get down to this point of equilibrium. Right? Because for producers, they're not just going to make something and hold on to it, right? Even though they might like to sell it for more money, but if they can't, right, they're going to find the price at which they can sell it. Or they just stop producing. That's another way to think about it, right? Maybe I just stop producing these units because there's no one out there to buy them, and then kind of end back up at that equilibrium point. Any questions on? So that shouldn't be too bad. And this is kind of the process I just described, right? Like the higher the surplus, there's pressure for individuals to lower the price, right? Whoever's trying to sell it to lower the price. As the price gets lowered, more people buy it, the surplus shrinks until eventually, right, we kind of end up back at this point where we're in equilibrium, right? The amount being supplied to the market is exactly the same as the amount being purchased or demanded. You can also think about it from the other direction, right? So instead of surpluses, maybe we have shortages. Maybe the price is too low. If the price is too low here, like let's say we're looking at $1, the quantity demanded is 21. So you could, if you want to think about this as the number of people who want to buy this good, there's 21 individuals out there who want to buy it, but the producers are only providing 5 of this good to the market, right? We would say there's a shortage, right? More people want to buy, like you think about, this is probably, you might not remember this. I was like not super young. It was like, there was like a 5-year stretch. It was like, there was always a shortage of like Elmo dolls at Christmas. Like it was like this huge thing. We're like, we're making enough. People were like, damn near killing each other to get these things like at stores. So anytime we have demand, right? People want more than what exists. We say there's a shortage. Right? So if you think about what our shortage would be here, it's really just the difference between quantity demand and quantity supply. So we reverse the equation from what we had before, right? When we had a surplus, we had to take quantity supplied minus quantity demanded, because if we have a surplus, we know the supply is always going to be the larger number. That's like the definition of the surplus. We have more produced than we have people willing to buy. Well, when we're looking at a shortage, we know that is implying that quantity demanded, right? The amount demanded is greater than supply. So when we're looking at that shortage value, the higher value is always going to be quantity demanded. So when you're calculating shortages or surplus, it doesn't really matter if you flip-flop these, because if I flip-flop these, like let's say to find my shortage, I took the quantity supplied minus the quantity demanded. I'm gonna get the same value, it's just that it's going to be negative, right? If I take 21 minus 5, I get 16. If I take 5 minus 21, I get negative 16. Well, we can't have like a negative shortage. That would actually imply a surplus, right? So these should always be positive values. So if you do, for some reason, like flip these, right, and you get a negative value, if you just remember, oh, well, if that's the right value, I flip-flop, right? I should always be taking the larger value, subtracting the smaller one whenever I'm calculating surpluses and shortages. So here we would have a price of $1, a shortage of 16. And we have the same sort of pressures going on if, that we did when we had a surplus. If we have a shortage, right, there's supply is way too low. Well, if I'm a producer and I'm currently selling Elmo dolls, whatever it is, for $1, and I'm like, man, there's like 16 more people who'd be willing to buy these, I could probably like raise the price a little, right? So producers start to raise the price. As the price increases, there you go, right? Well, now, at a higher price, it might necessarily, I'm going to want to sell more, right? If I can sell something for a higher price, like I'm okay with selling more units. And so as they raise the price, they also sell a higher number of units because at this higher price, it's now above the marginal cost. Right? Supply represents the marginal cost. So when the price goes from $1 to $2, well, now for the units 5 through 10, that new price is now higher than the marginal cost of those units. So the producers kind of provide them to the market. However, at this higher price, fewer people want to buy that good, and so we see quantity demand fall a little bit. So what's the implication? What is the end result of quantity supply going up and quantity demand going down? You see the shortage start to shrink, right? And the kind of this process continues. The price continues to increase from this point because the producers look out there and say, well, look, there's still more people who want to buy this good, so let me just raise the price a little bit more. As I raise the price, I'm willing to then provide additional units. So if I raise the price to $3, well, now for all these units, that price is now above my marginal cost. So I'll provide those to the market at the higher price. Consumers are willing to purchase a smaller amount. And this continues until we get to this point of equilibrium. So it doesn't matter if a market starts out of whack or something throws it out of whack, right? Let's say we see some supply and demand changes, and we know that the equilibrium point should be somewhere else. The new equilibrium price should be higher. But for whatever reason, like in reality, markets are slow to adjust sometimes. And so maybe like the retailers aren't adjusting their prices quick enough to what they should be. Well, it doesn't matter. It'll happen over time, right? We will end up at this equilibrium point eventually. It just may not be immediate. I think the way that sometimes we're going through these examples, it's easy to think about, oh, this supply chain, so automatically the price jumps up like that. Well, it may take time, right? Our window of time here could be a month, could be a year, right? Until we reach that new equilibrium, but we will eventually get to that point. A year is probably too long in most examples, but sometimes it can take weeks or a month. With some things, though, it's pretty responsive. Like it's okay to think about things changing almost immediately if you're thinking about gasoline prices. Right? They change very rapidly and adjust the factors very quickly. When it comes to things like real estate, they might take some time for that to play out in the market, right? Because houses aren't sold, there's a process. Any questions on kind of identifying shortages and surpluses, or just the idea? So if we're looking at this, and I know this is kind of hard to see, but I'll point out some values to you so maybe you can determine it. Right? So if I'm thinking about, and I started this one, so if I'm thinking about equilibrium price and quantity here, looks like it's 25 and 25. If instead the market price were set at 35, helping you out, right? At 35, the point I'm at on demand is 20. Also at 35, the point I'm at on my supply curve is 35. Okay? So given that information, that at that price of $35, my quantity demanded was 20, my quantity supply was 35. Which of the following is true about this market? So I'll give you a little time to answer this. I am hitting everything. Let's give you about, a minute to kind of think about this one. Kind of identify those quantity demanded and quantity supplied for you. Actually, maybe a minute and a half, kind of talk to the people around you, try to think about whether or not you have a shortage or a surplus and what the value of that shortage or surplus would be. Or if it's an equilibrium. Look like another 10 seconds or so, and we'll kind of talk about it. Everybody able to get in okay using the app today? We're good? Don't respond, whatever you feel, I guess. All right. If you haven't gotten an answer in, take your best guess now. Everybody able to get in okay on the mobile apps, hopefully sitting in a response on that, but 33, 34 of us. All right, close it out. So hopefully nobody answers A, right? I'm telling you, I mean, I started out telling you the equilibrium was at 25 for the price, units would be 25. Right? If I have the price set at 35, I said quantity demanded was 50, let's say 20, and the quantity supplied was 35. So if my quantity supplied is greater than quantity demanded, I should have what? A surplus or a shortage? Surplus. I've got too much, right? I've got more than what people want to buy, right? The value, right, is just going to be the difference between that quantity supplied and quantity demanded, which I told you is 20 and 35. So I should end up with a surplus of 15 units. Maybe. There we go. Right? Any questions on that? So if I was using another question, maybe I'll be nice and just kind of, well, we'll do this one actually. We got a little bit of time and we're pretty good on how much we've covered. So let's say instead, right, similar idea, but the price in the market is currently $15, right? So the point we're at in the supply curve is 15. So quantity supplied is 15. And the point that we're at in the demand curve is 30. So we've got a quantity demand of 30, quantity supplied of 15. The price were set at $15. Would I have a shortage or a surplus? And what would the value be? This one shouldn't be too tough, so probably not quite as much time on this. So if instead the price was at $15, right? We have a shortage or a surplus, and what would the value be? The quantity supplied is 15, and the quantity demanded is 30. Go to that, the 130 mark here, and then we'll talk about it. All right, if you haven't gotten an answer in, take your best guess. 34 of us here, close it out. All right, so if the price is $15, all right, I kind of map this out, right? But quantity demanded is greater than the quantity supplied at that price. So if I have more demand than supply, I have a shortage, right? There's not enough out there in the market. What's the shortage amount? Well, the quantity supplied was 15, quantity demanded was 30. So now I've got, instead of a surplus of 15, now we have a shortage of 15. Right? Any questions on this? Okay. So one thing I kind of started talking about I think I led in this idea of like, why is the price out of equilibrium, right? Well, sometimes it could be because the government comes in and sets prices, right? So you can think about, if they set the equilibrium, if they set the price below equilibrium, right, then we're going to end up right down here. Every single price below the equilibrium price, supply and demand is greater than quantity supply. So if the government comes in and sets the price below equilibrium price, I know I'm going to have a shortage. If they come in and they set the price above the equilibrium price, well, at all those prices, the supply, quantity supply is greater than quantity demanded. So if I set the price above the equilibrium, I know that I'm going to end up with a surplus. Right? So the government can come in if they, if do either one of those, we know what's going to happen. A really good example of this is in the 70s, right? We had this huge shortage because the price of oil was spiking. So the government came in, set an artificially low price. So what happens? Well, if the price is artificially low, right, or below equilibrium price, the amount supplied to the market is going to be way less than what's demanded, right? If you tell these oil companies, yeah, you can't charge $3 a gallon now, we're going to force you to only sell for $1. Well, guess what? A lot of what they were supplying now becomes unprofitable. They're just going to stop producing it and supplying it to the market, which is exactly what happened in the 70s. Right? Another thing that we can see, we'll kind of end on this example today. One thing that's kind of pretty common that we see is that the government likes to come in, and this will be the first look that we get at the labor market. Right? So we'll start doing more with the labor market as the semester goes on. We can think about this as the quantity of labor. Right? For now, we'll think about this as like simply the number of workers. Okay? And then the price of a worker is their wage, right? How much they're working for. So we would still have some supply and demand curve for labor. Right? And what ends up being happening, like the market for goods, there's a similar market, but for labor, right? For workers. And there will be, as long as we're looking at a homogeneous product, so we have to break down every type of job position to be a different market, right? There's a market for engineers, there's a market for phlebotomists, right? I'll ask you why I chose them as an example. But so we've got an equilibrium wage, right? And an equilibrium number of workers for every single job type. Well, if I come in and I set the wage artificially high, right, something like this, what's going to happen? Well, at that wage, the quantity supplied, the quantity demand right here, so I'm going to have a what? Got more supply than demand, so I've got a surplus. This is like a really bad thing. I have a surplus of workers, which means I have unemployed people, right? So if I'm setting prices artificially high, which is really what the government is doing in the labor market for certain positions, right? Like the minimum wage doesn't influence a lot of engineering positions, but it does influence a lot lower salary jobs. What you can actually end up with is you're trying to help out these workers by setting a higher wage, but what do? You just cause fewer companies wanting to provide, right, or to have a position for the workers. You end up with a surplus of workers, or you end up with unemployed individuals. So if you keep your job, minimum wage is great. But if you're one of those people that lost your job, right, because currently there's a number of workers out here, it's going to kind of follow that point, because it doesn't matter if you're willing to work. It matters how many companies are demanding your work. So that's another kind of way to think about surpluses and shortages. We'll go over the minimum wage again when we talk about government actions. Make sure you get on, finish that homework today. Other than that, I will see you guys on Monday. Have a good weekend.